Good afternoon. Welcome to our webinar on what the OT Bootcamp at the TAC is going to be doing.
We're here to answer any questions that you might have, kind of attract you to participating in this upcoming exciting event.
Before we start with questions, let's start by telling you guys what the OT Bootcamp is, how it goes, how the structure is, et cetera, et cetera. Steve, you want to start off with why we made the bootcamp?
Sure. I mean, operational technology is something that is under increasing pressure and attack by nation states and others. So our whole purpose in OT Bootcamp is to train perhaps existing IT cyber analysts to know enough about the operational technology side to advance their career, to make them more effective in dual mission activities. Now, it's not only just for those with IT cybersecurity experience, but we can take kind of all comers. If you have an interest in operational technology and cybersecurity in general, you will also find this, I think, content extremely interesting and maybe develop a career out of it.
Our course is meant as kind of an introductory course. So typically, right, we have lots of challenges out there in the world that require a lot of prior knowledge, and we're trying to build up that base knowledge. So in our course, we start you off with just trying to figure out what is operational technology. We introduce the different types of machinery that are common in OT fields. Things like PLCs, programmable logic controllers, HMIs, human machine interfaces, and EWs, engineering workstations. We teach you guys how to program them, how to recognize them, how they're used. We then move on to kind of the network of a typical OT field. We also talk about how can these things be attacked, and we give base attack scripts. We let people try them out, see what those effects are. And then we practice defending, right? How do we monitor the system? How do we ensure, and what do we look for when it comes to these types of attacks? It's meant as an introductory course to get you started. And then once you have this knowledge, you can then build off of that and continue to grow and increase.
So some interesting topics in the OT side of things. For instance, we covered one or two of the programming languages that are used to program PLCs, programmable logic controllers. The most famous of which, of course, is the ladder diagram language, which kind of goes back decades to how engineers used to operate, was just using relays and electric circuits. So that's particularly historically. We'll also cover more of a Pascal language type approach. It's called structured text. And so you can use either one of those languages. It's kind of important for an OT cyber analyst to understand what the heck is this computer doing? How is it programmed to respond to inputs, control outputs, to control a process, to make products, monitor state of systems, and the like.
One of the things that really does set this course apart from other current trainings is that it's very hands-on, right? We fully believe that you do not learn by listening, you learn by doing. So for example, when it comes to learning what these different types of PLCs are, we have you build a PLC, right? We're not simply just going and walking you through it. We have you create one, program one, and modify it, right? We don't throw you in. We don't just say, here's the sharks, go swim. We lead you into it, right? We give you all the guidance and all the structure that you need to be able to succeed. But it's a very hands-on course. You don't just hear about the attacks. You could complete the attacks. You send them out. You make them happen, and you see the effects in real life. So that's what makes this course so special.
And the hands-on aspect largely focuses on some important notions that are unique to operational technology. Field wiring. So PLC just doesn't sit there and, flash lights on its front panel. it's intended to sense things from the environment, from the particular process that's being monitored or automated. It can then provide signals to its output pins to actually control parts of the process physically. For instance, you can light lights with it. You can control other relays to handle higher current events. You can control motors, change their speed. You can turn on and off heating elements in ovens and other types of heaters. So all of those aspects, actually, we do cover in the OT bootcamp. Well, we'll have small examples of PLC ladder logic that do each of those things. And we actually end up, you're going to implement a particular station in our cyber range, which makes pizzas actually for sale. So you'll be tasked with programming your PLC to do the appropriate functions to control an oven that makes individual pizzas, maybe of 2 or 3 different types. And the last 2 days, we integrate your PLC into the overall plant and control it with scripts and programs that automate and coordinate all of the other PLCs to make this product. While we're doing that, we'll have students rotate in. A couple will focus on attacking the plant, seeing what damages they can do. And we'll have 2 other students probably doing the defensive operation, monitoring for alerts, figuring out, is this alert real? Is it going to cause damage to my process, affecting product quality? And then what should I do about it? So Payton will cover actually incident handling in an OT environment.
Mm-hmm. One of the things that when we were making this course, we're doing extensive research on what at least the foundational knowledge is. We had a lot of interviews with field experts and people who are currently working in the field. One of the things that they said most valuable is they've got a lot of people coming in who have no idea about field wiring, who have no idea about how electricity works, right? And so that's why it is such a core part of our boot camp, because it is one of the demands of the field. You have to understand how operational technology works before you can start to secure it. So we start off with how operational technology works, and then we start securing it. So it's only a week long. You may not end up, creating your own factory with the most perfect cybersecurity posture right off the bat, but it's a great way to get you started. You'll understand how things work. You'll be able to ask the right questions when you're in the field. You'll know who to talk to. You'll know who to ask about, hey, this looks fishy. Is this normal? Is this not normal? Right? You'll be able to get that process started, and you'll be able to make a meaningful dent in your career.
So some of you might be curious about how representative this course is to what you'll find in the real world. We're actually using an open source set of tools. One is called OpenPLC. You can find that online, and you can actually use it to make your own at home. In addition, we'll have some stations that exhibit other vendors' products, because it turns out the concepts across PLCs, it's almost identical. The differences are that each vendor has chosen to implement it in a proprietary and slightly different manner. So OpenPLC allows us to use Modbus as a control protocol. That Modbus allows you to change values at particular addresses in the PLC. Those addresses are often, connected to output terminal pins that control lights or read from sensors. So that's how PLCs actually work. They don't generally just operate by themselves. They generally need to be coordinated by some other higher level program. Sometimes you could associate with the concept of SCADA, supervisory control and data acquisition systems. So we'll expose you to quite a bit of that, especially during the last couple of days where we're actually operating the plant. That will all be done by a particular program that is automating, controlling each PLC across the entire plant. Modbus is somewhat attractive too because it has no security. So we're not about telling you how to secure an OT network. This is more about understanding what possibly could happen, especially if there is no security. You need to understand that to kind of properly then advise how such networks should be designed and secured. Other vendor stuff, we have another station using a Siemens PLC. Siemens is incredibly popular worldwide, if not notorious. So it's very important that we expose students to at least that primary vendor. There are others, Phoenix Contact, Emerson, Mitsubishi. We may not have all of those present in the lab, but the concepts viewed in them they're all the same, essentially. So we're able to teach that effectively using Modbus, and then you can apply that to other vendor technologies.
Something you said a little bit earlier that got me really excited when you mentioned the open source. Mm-hmm. One of the things that I think is super, super cool is when you leave our course, you walk away with all the tools that we use to kind of create that little plant. You're going to walk away with the Raspberry Pi that we're turning into a PLC. You're walking away with the ESP32 that we're going to be using as a simulated sensor. And you're going to be able to continue to practice those skills that you've learned in our course at home on your own time. In addition, right, you end up with a whole workbook full of notes and resources that we have accumulated for you to help you continue on this path and to help you learn in the course. So I think that is just super exciting. I love that we have that and that you can walk away with these real tools to continue learning.
So, very good question. What protocols are we using, especially with the lab, the cyber range, especially implemented by OpenPLC? OpenPLC really only supports Modbus. It might support DNP3 and another protocol. We're frankly just going to focus on Modbus. This is a concept-oriented course, not vendor-specific. And actually, it's boot camp, so it's preparatory to what? Well, we also have courses more in advanced OT where it gets into the vendor-specific protocols, vendor-specific attacks and defenses. So this is preliminary to allow students to be effective in the subsequent courses that are relevant to their career. So we currently don't have any AI implementations yet other than some rules that I have applied to the automation and monitoring. They are essentially about the topology. So it's not really AI, but it is pattern matching. For instance, why should a PLC ever be controlled by something other than its associated human-machine interface? So we can detect that, we can parse that by observing the traffic. So if some new node emerges on the network and starts talking to that PLC, that cannot ever be a good thing. So those are the foundational concepts that we illustrate using Modbus TCP. They then prepare you then to take those similar concepts into the more advanced courses where we're looking at other vendor-specific protocols. Another question? Well, we think we're kind of unique in this regard. One of the unique aspects is the intensive focus on hands-on. The other is really the way we teach the course. We're not there lecturing you. We are your coaches, your mentors. There'll be instructional materials that kind of give you the tasking, but you're encouraged to work with your neighbor as a pair in examining and trying to solve the problems. We then, circulate around and answer questions dynamically. Hands-on means you will have a Raspberry Pi right in front of you. You will be wiring it up to, typical circuits that we use in OT for control and sensors. You will be debugging the code that actually gets that to work, interacting with us if you have troubles. You'll be learning the editing environment to create these programs in the engineering workstation. It's just a typical PC with this software. So I think another unique aspect, we let you take the PLC and the ESP32 and components home with you. That is extremely valuable to us as instructors, because there's nothing worse than just having someone come in and be subjected to PowerPoints and then, oh, that's it. Great. Have a good life. No. We want you to actually pursue this, preferably at home. Start your own home lab. Add other things to it. You'll have the background to actually do that, as opposed to being perhaps stymied by, just looking at YouTube videos and figuring out how you might do this. We're going to lead you right to it. And we'll prepare you more for a career that focuses on the OT aspects, like in critical infrastructure. Why is this even important? Well, water treatment plants, they're all controlled by OT. Airports, all the systems they're in. Power distribution, control of dams and power generating plants and water levels. All of these are heavily oriented OT plants that form critical infrastructure. There's a huge lack of funding, career support for cybersecurity analysts to know about the OT, to apply that to critical infrastructure at the state and federal level. So those are the ones we're really trying to accelerate and get into those careers.
I think another thing is one of our goals was to try and keep this course as affordable as possible, right? Because a lot of the existing courses you just can't afford, right? That they're crazy expensive because this knowledge is so valuable. But we wanted this to be accessible so people can really start their career and really grow, because this is so fundamental. And if without it, you have a really hard time breaking in and getting started.
Another question?
Labs include red team versus blue team exercises?
Yes, it does include red team and blue team. Essentially, the culmination of the course is kind of a red team, blue team, right? We have one team defending, we have another team attacking, and then we have the rest of the team, the rest of the students operating the plants that they've created throughout the course. We then rotate through so everybody has an opportunity to do each of those tasks and really get the chance to experience that kind of red team, get to experience that blue team.
The important aspect about that too, and I think a uniqueness, say you're a defender in an OT environment. You're probably watching some sort of computer screen, some SIM, security information and event management system. And maybe an alert pops up and says, hey, we've got a new node on the network. It's starting to communicate with this PLC. Gives you an alert. Well, you as the analyst, what are you going to do? So we'll actually give you kind of incident handling guidelines. What's the first thing you probably want to do? You want to figure out what PLC is that in our network, and then who's responsible for it. You really can't take any actions yourself as the cyber analyst, but your job really should be consult with the operating engineer responsible for that PLC. Say, hey, we see something really weird going on. Is that you doing something, or are we being attacked? That's an important, vital communication that has to happen. That's one thing we're training you to allow you to have that the vocabulary and the concepts to interact, very specifically with the responsible plant engineer. If it turns out to be some problem, the engineer is the one that'll actually mediate the problem, and you as the analyst will have to document and report upwards or whatever to describe what has happened, maybe identify other trends that are happening. Typically, OT plants are not hacked in just one little event. Typically, it's a coordinated effect. And the sooner you can identify what's happening, the safer that operation will be.
Are there cyber ranges as a part of this class? If so, can you describe?
Love to. So upstairs in our training environment, we actually have what we call the Tactical MREs Cyber Range. TAC because that's who we are. MREs because it's a baking food preparation facility. We think possibly to distribute to other soldiers worldwide to have them enjoy our pizzas. Anyway, there are 16 PLCs operating a coordinated role. There's a power plant, there's a dispensing operation, a mixing, a layout operation, multiple ovens, packing, and shipping. All of those are controlled by this automation in Modbus that I've been talking about. So that range is operating even now, 24 hours a day, all day long. And we have it making, fictitious pizzas. When we conduct a course, we'll take out some of those PLCs that constitute the range. It'll still keep running. Students will prepare their PLC to perform one of those roles. And then the last 2 days, we integrate their PLC into the plant and operate, attack, and defend on that range. The realistic parts about that, OT is continuous. The cyber analysts and client engineers, they're not. They come and go. So this is the authentic aspect about what we're trying to train in. There's a concept in cyber analysis that I call jacking in. So an analyst comes on site, logs into the SIM, and starts monitoring. That's the jacking in. It's kind of reminiscent of being a telephone operator back in the day. So we will actually mimic that in our last 2 days exercise as the students then rotate different roles. Some of them operate the PLCs, a couple of them will go attack, a couple of them defend, do that for about half an hour, and then we rotate. So everyone gets the experience of having each of those 3 roles understand deeply what is going on.
Are there recommended reading materials for IT practitioners without OT experience prior to the bootcamp?
Yes, we really don't require anything. It would certainly be helpful if you maybe did a little bit of research, YouTube, Wikipedia, whatever, to at least be familiar with some of the concepts. We mentioned many of those concepts on the web page, the website. You might refer to topics actually we just talked about. The more that you can prime your brain to understand what those terms mean so that you won't be hearing them for the first time, the better. It would be really cool if you had some minor programming experience and do something in Python or batch script or C, C++. We don't require any of that, and we'll give you examples that are pretty much ready to go. But the more that you can, play with that ahead of time, the better you'll be able to understand what happens in an OT plant, how the nature of a PLC is so drastically different than a laptop computer.
I do want to highlight that kind of coding primer because coding is a very vast field and it can be very difficult if you're seeing it for the first time. We will obviously help you and walk you through it. However, if we're spending that week focusing on OT cybersecurity, it's very difficult to also include a lot of programming in there. We do teach a little bit. We will help refresh. We will help you understand and make sense of it. But especially with the coding, it's really good to have primers on at least how to read it and make sense of it. But other than that, we'll walk you through, you use Linux computers, we'll help walk you through how to do that. We assume that our students will not have any OT experience at all. So we do dedicate a fair amount of time making sure all of those OT concepts are fully fleshed out for everyone. Of course, we would love for you to start doing research as soon as possible because that's going to help you the most.
And then in field wiring, so we're not expecting you to be an electronics engineer. That would thrill my heart, but no, you don't need to be. We'll give you components. They'll be kind of of small nature and not dangerous at all. But essentially, they use the same concepts as larger scale physical devices do in the real world. So we'll talk a little bit about Ohm's law. We'll talk a little bit about voltages of signals, current. We'll talk about the characteristics of a couple simple components like resistors, relays, light emitting diodes, Maybe we'll throw in a motor or a relay. All of these things are totally authentic out in the real world of OT, except that in our lab, they're this big versus out in the real world, they are typically much larger.
They're small for safety. And if he just spat out a bunch of words at you, don't worry, we cover all of that. We will teach you it. It will make sense. Do not be scared. So, right, this is very hands-on. You're building, you're networking it all together. So this is an in-person course. Currently, we do hold it at the TAC, but we do have the availability to move to wherever you guys are. So if your company wants to have a training, we are happy to pack it all up, bring it all over. You just got to give us a space and a whiteboard.
And a price.
Then some power, right? But it is an in-person course, to answer your question. To start off with kind of why OT career, right? I find this super interesting, so I might nerd out just a little bit. Right, previously, OT environments didn't have to worry about cybersecurity because they were completely air gapped. There was no remote in, there was no internet connection in these networks. So in order to have an attack, you would have to kind of, leave a USB in the parking lot and hope a employee comes and plugs it in there, right? I think that's how Stuxnet became a thing. It was a USB. But those attacks were highly sophisticated. They took a lot of dedication. People kept trying to get in. They had to have physical access. But, post-COVID, right, we've got all of these new technologies. We've had a pandemic to make us all go home, and we need to figure out how to get these plants going while keeping everybody safe and healthy. So now we have technology that allows us to remotely control these devices. Remote control means that there is some way for remote attackers to also get in. So now we have this emerging threat where these OT systems that, maybe the manager does, maybe you think your network is air gapped and it's actually not because of some misconfiguration, some new tool, some vendor thing, right? So OT cybersecurity is an emerging field. It is new, it is shiny, it is scary because especially with OT technology, this is the stuff that can get people seriously hurt or killed, right? Let's take water treatment, right? If I stop treating the water, people are going to get sick. People you don't have drinking water. What happens then? If we take out the power lines, right? We are dependent upon this, right? We lose heating, we lose cooling, we lose a lot of these functionalities that we have learned to depend on. And so this is an extremely important field. This is an extremely important subject, and it is growing every day because there are new threats out there. There are new attacks. There are new ways in that we need qualified cybersecurity experts in OT to secure this. And we got to start somewhere. So we're going to start with the foundations. We're going to build up, and we're going to have a very secure nation. Let's do it.
We're making suggestions even at the legislative level in states to say, this is kind of a state problem that needs to be addressed. There is no cybersecurity monitoring force, especially for critical infrastructure in any state as far as we're aware. So that is definitely what's in our crosshairs, to train you individuals to be effective in that regard. Once we have funding and other types of structures set in place to actually fund those type of operations, we would prepare you then to respond to that call. Just the OT bootcamp probably isn't sufficient to fully do that, but there are other subsequent courses that will really prepare you for vendor-specific types of things that you would encounter in critical infrastructure, defending at the state or federal level.
Will there be tests and exams? Are there access to materials after the course? And does TAC provide any workforce development assistance after?
Tests and exams, this is, we believe a lot in project-based learning, right? There are little quizzes, but overall, if you don't understand the concepts, you will not be able to complete the tasks that we are asking you to do. So it is project-based because you make the project, you're learning at the same time as demonstrating your understanding. So we know that once you've passed this course, you've passed, right? We know that you know your content because you have completed all of the tasks we have given you.
And then for learning materials, we use a learning management system. So you'll be kind of expected to contribute your answers to certain problems into the LMS that helps solidify the concepts in your mind to be able to describe it to another individual.
Yep. And those resources on the LMS, we encourage and welcome you guys to download those, keep those, store those in your computer. We send you off with a workbook full of resources, full of notes and helpful hints and things that we found useful in creating this course and, studying all of this for you guys to use. And I mean, we have tracks to help you continue. We've got subsequent classes that we encourage to help you continue your education post this.
And then with respect to career training, follow the TAC. We routinely conduct lots of interchange with local governments, with local businesses, well, not even local, global. And our focus is certainly on OT and the careers that are implicit in providing and securing that type of environment. So we would be one source for knowledge about careers, but I'm sure through your activities here, you'll find other sources as well to use to track for career opportunities. And this is just one of those possibilities to learn about it. Programming examples, that's what you will definitely get. You'll be able to download those, take them with you. We give you most, half, at least a start, and encourage you to kind of complete the programming examples. Your own laptop, it would be okay. You won't be able to use that in the class context. We have the laptops very specifically configured to be a electronic workstation, engineering workstation, the HMI, to have the editor on it. If you did bring your own, it might be easier for you then to get copies of those tools to use in your own lab at home. So it's you won't be able to use them in the plant, but certainly you can use them to kind of take your own notes so that you have more of the resources available when you leave.
For the programming, if you're curious about what languages we use Arduino IDE, which is, I think, C++, C++, and we use Python. So those are the two languages that students will be exposed to, aside from the PLC, ladder logic, and a little bit of structured text. So in terms of certifications, we provide continuing education credits for, I think, ISD2. Yes, ISD2. Okay. So you get continuing education credits. You get a nice little sheet of paper saying that you completed the OT bootcamp.
Yep, and beyond that, there is not yet an officially sanctioned certification process. That's actually a rather expensive prospect to engage in. We're hoping to encourage the industry to kind of recognize this kind of training. It's early on, so part of it is you can just claim that you were here at the TAC and passed through the OT bootcamp. That will have certain resonance out there because we are kind of unique in that regard.
In terms of the price, I believe it is currently valued at $3,999. Yeah, $3,999, saying that clearly. And if you have like a team that you want to train, we do encourage you to reach out and negotiate with us because we want to train. We want you to succeed. But yeah, we have group discounts available.
So if your current role involves or could involve operational technology, you will be immediately starting to be effective in that regard. This is, foundational knowledge to get started in that field. If you're looking to get into it, then this is the discussion to have with, your employer. Hey, I now have some skills in OT. How can we expand, the company's business to extend into that area as well? Because there certainly is a demand for that service. That's a discussion then that we help you maybe have with your employer to say, hey, let's extend our IT services into OT defense as well.
You'll be able to immediately start speaking intelligently about the field. You'll be able to immediately start knowing who to ask, where to go, right? One of the challenges about OT is that it is so varied across various systems. So there's no uniform OT. So if you were an OT expert at one factory and then you move to another, it's going to be completely different. So we're equipping you with the skills so you know what to ask, you know who to talk to. And if you ever are, getting a job interview for OT cybersecurity, you can start saying the right things and start getting those jobs.
And there's another aspect too that we really haven't touched on. We're not expecting everyone to come out here and then all of a sudden jump in and be an analyst. There are other actual important roles that we're also trying to train on. For instance, an OT configuration design auditor. Much of the OT infrastructure throughout the world is very, very poorly designed. Well, nobody knew any better, or they can't afford it. So in the combination of government and other types of policies, combining that with a desire to make plants more compliant, there will be roles for OT aware people performing this auditing function, recommending, hey, these are your vulnerabilities. These are critical. You really need to fix those. And oh, by the way, here are the ways to start repairing some of those. So it's not necessarily just about being a cybersecurity analyst for OT. There are other very significant careers that really haven't been, developed yet. That's what also we're trying to train for. The same training will prepare you for subsequent training in the details of OT auditing. You might look up the concept of CMMC on various websites. That was another program that emphasized compliance, in this case, in terms of defense contractors, compliance of their information systems according to CMMC guidelines that will govern their configuration. There will need to be an equivalent capability and thrust that applies to the OT side of that conversation. Another unique thing about our OT bootcamp, we really have this emphasis on making you aware of what it is like to operate in a plant. Typically out there could be, in any particular operation, there could be hundreds of PLCs, each of which is monitoring and controlling hundreds of points by itself. Obviously, analysis and defending cannot pay attention to that many things. So we developed this notion of critical operating parameters, like the temperature of your water heater. If that gets too high, if someone goes and manipulates the set point to be way above the boiling point, what's going to happen? Well, the tank will explode. Probably not a good thing. Directly affects safety, probably productivity as well. So we focus on these notions. Yeah, there are lots of points that are being monitored, lots of points that are being controlled, but there are a few of those that are critical by themselves. We kind of focus on understanding what those are and then using the tools to monitor those specifically. Those are the ones where we would typically monitor out of range values and generate alerts to then drive an analyst to maybe declare an incident, to have that conversation with plant engineering. So it's not about monitoring everything under the sun, but it is about understanding what is important, being able to prioritize what you're monitoring and dealing with them in a priority fashion if you see some sort of alert or condition. No zero trust concepts at this point. I think we would expect that in the more subsequent, more in-depth training. Zero trust is often implemented by firewall-like systems, by very specific configurations of, who's allowed to talk to whom, when, under what conditions. We have not seen a lot of that being implemented actually out in the real world, and we're not really covering that concept at the boot camp level. Good question. So in our case, Modbus, everything's vulnerable. Everybody can read, write, change anything, anywhere. So again, we do this for training purposes to show you how bad it could be and how any real world implementation had better secure that aspect of it. Device to device, that is a common vulnerability actually out in vendor and proprietary systems. There are known hacks where you can develop a payload that goes and maybe shuts off your Siemens PLC. We have folks out here in our courses that actually train on those types of vulnerabilities. But yes, all protocols are vulnerable. All systems are vulnerable. It's important to them to know what's possible so that you can focus your monitoring and securing and configuration in the right areas to be as safe as possible.
I don't think I've been asked that before. Do we write letters of recommendation? That's the first time we've been asked that. If you're recommendation worthy, sure. How about that?
We could say we know you. Yep.
So it looks like it's about time for us to wrap up. Just as a final thing, my name is Payton Buss.
I'm Steve Hutchinson.
We created and are currently running the OT BoOTcamp. We're really excited about this foundational course to get you guys started on your journey in OT cybersecurity, whether that be as an analyst, an auditor, a network engineer, wherever this takes you. We look forward to supporting you, and we hope to see you in our course soon.
Please come and join us. Learn with us.
We're located at the link in Columbia, Maryland.
7000 Columbia Gateway Drive.
You can also find us at thatch.tech.